Hello everyone. Long time no see. Unfortunately, I had some work to do and I was a little bit busy, but I have decided that I need to come back and to continue my um, road to the Google, let's say like that. And from today, we will start a series of videos related to binary trees. If you are not familiar with binary tree, I really recommend you to read about it. But if short, actually it looks pretty similar like inverted tree. That's why this data structure is called like a tree. But if to compare it with a structure which we have already seen in previous videos, I would say that for me it's pretty similar with linked list, because if you remember, we in linked list have a node which points to the next node and so on. Here the situation is pretty similar because the root node, in that case it's 4, points to two subtrees, left subtree and right subtree. So it points, let's say, to this, bucket, which also points to the left and right buckets. But actually it has a little bit different naming. If I don't make any mistake, it's called leaves or something like that. I'm not sure, you can check. But the idea is this. So let's check the first exercise. The condition says that we need to design a method that inverts a binary tree, frequently referred to as flipping or mirroring a binary tree, such that every left pointer points to the old right subtree, and every right pointer points to the old left subtree. So we need to create a method. It can have a different naming, but in that case, in that tree, where like argument we will pass root of the tree. Again, it's this value 4 in this case, and we need to return the root of the inverted tree. So below we have an example where initial tree looks like this, and after we will revert this tree, it will look like this. So what have changed? It's pretty simple. So if you notice, here we have this subtree, and we just switch the left subtree with right subtree. So now the root will point, so the value of this root not will be in the left side, this subtree, but this subtree. So the idea is pretty simple. I hope you understood. If not, please write in the comments and I will try to explain more specifically. Now let's go and check an example how this algorithm which I want to use will help us to solve this task. So here you can notice that we have the subtree, this one, and the main idea is that we will need to go to the bottom of this subtree and from there to start to switch our elements. So the idea will be that we will start from the root, we will go to the left subtree initially until we reach the bottom. So we will go to 2, then we will go to 1, then we will go here, let's say, and we will see that there the value is null. So if the value is null, we just go back to our initial root and start to move through our right subtree. We will go to the right side, and there we also notice that the value is null. We will go back to our root and we will switch null from the left side with null from the right side. Then we will complete to execute our operation here, and we will go back to our root. and we'll start to make the same operation for the right subtree. So we'll go to tree, and we will go to left. We will see that there again we have null. We will come back to 3. We will go to the right. We will see that there we have null. We will come back and we'll switch null from the left with null from the right. And we will go back to the 3. Here we also executed all the operations from the right subtree, and we will go to the initial root, which is 2. And now we can switch this subtree with this subtree. So we will then go to the 4, and here we will execute the same operation which we have done in the left subtree. So let me show you how does it work. So we will start from the root. We will go to the left subtree, which is this one. Then we will go again to the left subtree, which is 1. Then we will go below to the bottom, and we will see that there we have null. So we can go back to our subtree, and now we can start to iterate through our right subtree. We'll go there. We again will see that we have null, and we will go back to our subtree, to our root, which is 1. And now we can switch left value, which is null, with right value, which is also null. Okay, we have completed all operations for this root. We go back to our initial root, which is 2, and start to make the same operations in the right side. So it will be the same situation. We will complete all operations here, and we'll go back to our initial root, which is 2. And now we will switch this root with this root. Perfect. And now we can go back to initial root, which is 4. This one, because we already complete all switchings, let's say, in this left subtree, and we will do the same operations in right subtree. So in the end here we will have, instead of 6, 9, and instead of 9, 6. Let me very fast to show you what we will have in the end. Yeah, and here you can see how we switch these values. Yeah. And now we have finished all operations in right subtree. We go back to our initial root, and now we can switch this left subtree with this right subtree. Perfect. So that's how this algorithm is working. And now let's continue and try to implement this. And for the implementation, we will use recursion probably, which means that we will call the same method inside itself. Yeah, so we will see in the implementation. So let's start to implement this algorithm. And like I already mentioned, the tree, it's pretty similar, we think, at least. And also in tree we have nodes. And what a node contains? A node contains value. It also contains a pointer to the left subtree and the pointer to the right subtree. So let's create the structure. For that I will use inner class, and let's call it tree node. Now let's define some fields. First, let it will be value of type int. Also, we will need a pointer to the left subtree and a pointer to the right subtree. Okay, that's it. And now let's create a constructor in order to define a value. Okay, so the structure for a node is ready. Now let's create our method, which will invert this tree. Yeah? So public, we need to return a root. Yeah, so a root is a node, so it will be tree node, and let's call it invert tree. Like argument, we will take start point of this tree, which is root. Okay, perfect. And how I've already mentioned, in order to solve this task, we will use a recursion. So a recursion is then we call this method inside itself. And we will need to understand when to stop this recursion. And we already have seen in the examples that the main idea of this algorithm is that we need to go back to the ends of the tree. And when we know that we are on the bottom, we know it in case if the value is equal to null, it means that in that subtree we are already on the bottom, so we can return the value. So let's put here a condition that if root is equal to null, then in that case let's return its value. In that case, we will stop the recursion and we will not go further. And another thing which I propose you to define from the start is what we need to return. And we need to return our root initial node, which has pointers to all his subtrees. So it will be root. And actually that's also one of the reasons why we start to switch our elements from the bottom, because in the end the last operation will be executed on our first root node, and it will be easier to return it. Yeah. And now what should we do? If you remember, also how I already mentioned, that we don't start to make the switching on the top of our tree. We need to do that on the bottom. And in order to reach this button, we need to call recursively our method, which is inverttree, for left subtree and for right subtree. And what does it mean? It means that we will reach the bottom and we will start to process subtrees and switching elements between them. So if we talk about, let's say, this node, root node, this call, recursive call, will be executed only after this method will process all elements. So what does it mean? It means that we will start to execute operations for right subtree only in that moment. Then all elements from the left subtree will be switched between them. So all switchings will be already performed, and we will start to execute the same operation for the right side. Yeah, and we need to save somewhere the result of this execution. Yeah, for that let's create some variables. Let's call it left, and here it will be right. Yeah, so left will contain the pointer to inverted subtree from the left, and here right variable will contain the result of inverted tree from the right. And in order to invert it, here below we will need to change the pointers. Yes, so root left will point to the right subtree, and root right will point to the left subtree. And in the end, we will return the root with inverted subtrees. So how does it work? So in the left, you will contain the left subtree with inverted nodes. Then this recursive method will be called, will invert all nodes for the right subtree. So here you will have the inverted subtrees from the left, here you will have inverted subtrees from the right. And now you just take the root for left subtree and right subtree and just change the pointers. Yeah, and that's the idea how you can implement this algorithm. So that's the solution. Thanks for watching, and we will see in the next videos. Bye. And yeah, this is not the end. I just want to be clear that root is not only the first node, yeah, this one. But also, for example, 2 is root for this subtree and this subtree. 7 is root for this subtree and this subtree. And 4 is root for this subtree and this subtree. Yeah, so just wanted to be sure that this moment is clear. And again, if you have any questions, please leave a comment. I will try to help you, because actually we like a group of people who tries to reach and to get a position from Google. So we need to help each others. So thanks again for watching, and bye.